Yes, doctor.
Okay. So yesterday we introduced planar kinematics of a rigid body, and we have seen that we have three main modes: translation, rotation about fixed axis, and general plane motion. And we introduced the main formulas in translation and rotation about fixed axis. Okay. So today we will do some problems on the rotation about fixed axis. Then we will move to the general plane motion. So to begin with, let us do this problem. A cord is wrapped around a wheel which is initially at rest. If a force is applied to the cord and gives it an acceleration A equals to 4t, where t is in seconds, determine as a function of time the angular velocity of the wheel and the angular position of OP in radians. So this is a very simple problem, just for you to see the analogy between what we did previously and what we are doing now. So here they gave us the linear acceleration A. Okay, A is the linear acceleration of the cord, and it's equal to 4t. How can we move from the linear acceleration to the angular acceleration?
A equals to alpha r.
Very
AT.
good, because here, look, whenever you have no slipping, okay, when I have no slipping condition between the cord and the wheel, okay, I can write this is equal to alpha times radius of the wheel because of no slipping condition. In general, when they don't say anything, so we have no slipping condition. Okay. They should be clearer and they should say that we don't have slipping. But of course, in the exam, this will be clear. So A equals to alpha r. The radius is 0.2 meters. So we can deduce that alpha is equal to 40 over 0.2 equals to 20t. So here alpha is a function of time, and we know the function. So to get the angular velocity, all we have to do is to apply integration, okay, because alpha is derivative of omega with respect to time. So just we need a boundary condition. The boundary condition is given here because they said that the wheel initially starts from rest, okay? So since the wheel starts from rest, omega 0 equals to 0. So just I have to integrate and say omega equal to 10t squared plus omega 0, which is 0. So this is omega. And now to calculate the angular position of line OP, if I consider that the boundary condition at t equals 0, theta equals 0. So if I integrate omega, I can find theta. Okay, so by integrating omega, I get that theta is 10t cubed over 3. Okay, that's it. Let us do another problem. The end of rod R maintains contact with the cam by means of a spring. If the cam rotates about an axis through point O with an angular acceleration alpha and an angular velocity omega, determine the velocity and acceleration of the rod when the cam is in an arbitrary position theta. So what do we have here? We have, this is a spring connected to a rod, and the rod is at this level in contact with the cam, okay? And as you can see, as the wheel will rotate, this distance will vary, which will cause motion of the rod, okay? It's oscillation of the rod. So here, we want to correlate the motion of the rod with the rotation, okay? Our purpose is to find the velocity and acceleration of the rod function of our variables, which are theta, omega, and alpha, which characterize the rotational motion of the wheel. Okay, so to be able to do this, whenever I want to relate linear motion to rotational motion. So I should relate x to the coordinates of rotation, the components of rotations, which is the angular position theta. So if I look at my figure, I can by geometry relate x to r and theta, because as you can see here, x can be divided into two equal parts, okay? And each part is equal to r cosine theta. So each part is, these two parts are equal, each being equal to r cosine theta. So since x is 2r cosine theta, then I can now relate the velocity of the rod to the angular velocity of the wheel by just doing the derivative. Because if I write x equals 2 times r, which is a constant, times cosine of theta. Now, first I need to determine the velocity of the rod. So v by definition is dx by dt. And here I will use the chain rule because x is function of theta. Since r is constant, the derivative will be minus 2r sine theta. So this is the derivative with respect to theta. To obtain the derivative with respect to time, I should multiply by d theta by dt. And d theta by dt is the angular velocity of my wheel. So this is omega. In this way, I found the velocity at any instant function of theta, which is the angular position of the wheel, and omega, which is the angular velocity of the wheel. Now, for acceleration, also the definition of acceleration is a equals to dv by dt. So now I will derive this expression, okay? So this is equal to, first here I have the product of two functions, sine theta and omega. So I will do u prime v plus v prime u. I will start by deriving sine theta. So it's minus,
Doctor,
naam? Yes,
I have a question.
yes.
Can you please repeat why طلعت ال x 2r cosine theta?
Yes, sure. If you look at your figure here, this is a disk, okay, of radius r. This length here is r, and this length is r, okay? This is an isosceles triangle, and the angle here is theta, okay? X is, if you want, the base of this triangle, okay? So since it's an isosceles triangle, this angle here is equal to this one, okay? And both are equal to theta. So how you can calculate the length of the base? Because in isosceles triangle, if you draw the height, it will pass by the middle of the length, okay? So here, if I draw the perpendicular, it will cut into two equal parts, and each part is equal to r cosine theta, okay? This is why x is 2 times r cosine theta, okay?
Okay, thank you. Yes.
Well, so now, if I continue the derivation, I have first, the derivative of sine theta with respect to time is cosine theta, and don't forget to multiply by omega because of the chain rule, okay? And already we have omega, so omega times omega, it will give us omega square. This is u prime, okay, v. Now plus v prime u, so it is minus 2r sine theta times the derivative of omega. The derivative of omega with respect to time is alpha. Okay, so times alpha. Okay, so it is this one. If it's not clear, I can rewrite it. في مشكلة بالderivation sheet, this is the derivation. Minus 2r cosine theta omega square اللي هي u prime v. u prime هي cosine theta times theta dot اللي هي omega. فبيصير عندنا minus 2r cosine theta omega times omega يعني omega square. And uv prime minus 2r sine theta times the derivative of omega with respect to time, which is alpha. Okay, so in this way, we can see here again the derivation. So as you can see here, first we find x function of theta, then we derive the first time, we get velocity, then we derive the second time, we get acceleration function of our parameters theta, alpha, and omega. Okay? Any question on this problem? Okay. Let us do another one. The large window is opened using a hydraulic cylinder AB if the cylinder extends at a constant rate of 0.5 meters per second. Determine the angular velocity and angular acceleration of the window at the instant theta equals to 30 degrees. So in this problem, we have a cylinder, AB, a hydraulic cylinder, that is extending at a rate of 0.5. What do we mean by this? The length of this hydraulic cylinder is not fixed, okay? To open the window, it should extend. So this is S. They gave us S dot. S dot represents the rate of opening, if you want, because this length is varying, okay? So S dot is equal to a constant in this problem, equals to 0.5 meters per second. Now, what they want us to find is to determine what will be the angular velocity and the angular acceleration of the window when theta is equal to 30 degrees. So here also, okay, I want to try to correlate the angular motion of the window to the extension of my cylinder. Okay, so I should try to relate theta and S, and then I can derive theta to find the angular velocity, and then derive again to find the angular acceleration. Okay, so the first step will be to find a relation between S and theta using geometry. So you know that if you look at your figure, OB distance is constant. This is 1 meter. And OA also is a constant length, 2 meters. So what is varying is just S and theta. Then we can relate them using what? Which law? Which law we can use here in this triangle?
Sine law.
Cosine law. Okay? And look, you know these two lengths and the angle in between, and you want to relate to S. اوكي هلا فيك تعمل ساين لو بس انت تتعمل to do sine law بصير بدك تجيب كمان هول الانجل يعني it's more complicated to relate directly S and theta you can use the cosine law. So from cosine law we can write that S square is equal to 2 square plus 1 square minus 2 times 2 times 1 cosine theta. Okay, so S square is equal to 4 plus 1, it's 5, minus 4 cosine theta. Okay, now our purpose is to find a relation between S and theta. This is the relation. It's very good. This is the first step. Then, in order to determine the angular velocity omega and angular acceleration alpha, then we should derive this expression with respect to time. Because when you derive this with respect to time, omega and alpha will appear. Okay? So first, if we derive the first time, what do we have? The derivative of S square is 2s times ds by dt. So 2s times s dot equals to the derivative of the second term with respect to time. This is a function of theta, so I will use the chain rule. First, the derivative with respect to theta will be plus 4 sine theta. And then I multiply by theta dot, okay, in order to have the derivative with respect to time. And theta dot represents omega, which is the angular velocity of the window. So as you can see here, I obtain an expression for omega function of s, s dot, and theta. So I can say now that for theta, they asked for theta equals 30, what will be omega? All I have to do is to replace first theta by 30 in this equation, I get s. And s dot is given to be 0.5. So just I replace s at 30 degrees and s dot by 0.5. I can get then the only unknown will be theta dot. I can find it. Okay. Now, the next step is to calculate the angular acceleration. So to find the angular acceleration, I should now derive this relation with respect to time. Let me put it again. So we
دكتور
have, yes,
بس اس برايم كيف نجيب الفاليو تبع
yeah, راح ارجع عيد. Okay, I will repeat it. You have نحن جبنا انه s prime given, s prime, look, extend at a constant rate of 0.5. So s dot is given, it's a constant. S dot equal to 0.5, okay, which is a constant. فنحن وقت عملنا الديريفيشن شو طلع لنا؟ 2 times s times s dot equals to 4 sine theta times theta dot. مظبوط? So now what can you say from this relation? You can say that theta dot اللي هي omega is equal, you just replace s constant, okay? يعني عندك 2 times 0.5 times s, okay, over 4 sine theta. So the general expression of omega is equal to 0.25 s over sine of theta. Okay. Now, in particular, at 30 degrees, you replace theta by 30, so you can get what is s, since s was calculated function of theta, and you can calculate omega at 30 degrees. Okay. Clear for the person who asked the question?
Yes, doctor, thank you.
Okay. Now, the next step is to calculate alpha. Look, to calculate alpha, you can go several ways. You can say I will derive omega with respect to time. I will do the omega by dt. Since here I'd already found the expression of omega, which is 0.25 s over sine theta, I can just derive this function with respect to it. Okay? بس هون عندي u over v وأوقات بتكون كتير complex الفورمولا. So in general, what I advise you to do is to derive الفورمولا الأساسية قبل ما تاخدوها لتاني. لأنه when you take the terms to the other side, sometimes you will have a very complex derivation. So to be on the safe side, أحسن رجعوا لهالفورمولا because it's easier to derive it. Okay? نحن قلنا انه s dot is constant equal 0.5 يعني 2 times 0.5 equal 1 هول بيلغوا بعض فبتطلع الايكويشن s equals 4 sine theta theta dot. خلينا نعملها derivation. So if I derive this relation with respect to time, what do I get? The derivative of s is s dot اللي هي constant equals to 0.5 equals to the derivative of the second term. Second term هو sine theta theta dot, okay, which is u times v. So I will derive derivative of sine theta هي cosine theta times theta dot, okay. already عندي ال v هي theta dot يعني times theta dot square, so times omega square أكيد times 4, okay, plus فينا ناخد ال 4 into factor plus the derivative now uv prime يعني عنا sine theta theta dot dot, so plus sine theta, what is theta dot dot هي alpha, so plus sine theta times alpha. So هون it's much easier derivation. Then you can find alpha function of omega and theta and you already calculated omega in the previous step. Okay, so all you have to do to find alpha at 30 degrees is to replace theta by 30 and to replace omega by its value at theta equals to 30. Okay. Any question on the derivation here? So we can see in summary together again what they did. So first we apply the cosine law to get S function of theta. And in particular at theta equals 30, we can replace to get the value of S. Then we derive the relation with respect to time. A first derivation will give us omega function of theta and function of S dot. Okay. So by replacing, we can get the value of omega. And then finally, we derive a second time to get a relation involving the acceleration as function of omega, alpha, and theta. And then we can replace to get the value of alpha. هلا هون مثلا عملوا لنا general derivation. اوكي بس نحن الاس dot constant. اوكي so بما انه الاس dot constant يعني derivative of s dot with respect to time اللي هي s dot dot بتكون zero. هلا هون هن عملوا general case يعني in case منا zero I should do this derivation. بس لانه هي constant انتو you can directly انه say انه because it's constant من الاول you can replace it by its value. So this will facilitate derivation for you. لانه بما انه هي constant هيدا term will cancel out. Okay. So this is about we have practiced on how to relate linear coordinates, يعني linear motion to angular motion. Now we will see relative motion analysis. Okay, so we will do analysis for the case of for the most general case, which is general plane motion. So as we said, we have three types of rigid body motion: translation, rotation about fixed axis, and general plane motion. In case of general plane motion, the motion can be described as combination of translation and rotation. Okay, and we will see how we can do this. This can be done by dividing motion, okay, into two parts. And this is possible by using the relative motion concept. What do we mean by this? So if you take any object in motion, let's say AB, this rod is moving, okay? What I can do, I can say I will put a frame at A, and this frame is translating, okay? If I am at A, if I stand here at A and I look at B, if I have a general motion, B will do what about A, do you think? إذا أنتوا واقفين على A، شو حتقشعوا B عم يعمل؟
It will only rotate.
It will only rotate. Very good. Why? لأنه distance between AB is constant، ما بتتغير. وبما أنه الفريم ماشي مع A، okay, and it is just doing translation، مش عم يبرم مع البودي. So حنقشع إنه B عم يبرم. So in this way, I can divide the problem in translation of A plus rotation of B relative to A. This is the idea. عشان هيك بيقولوا إنه in general motion we can divide the motion into translation plus rotation. Okay? And how can I put it in equations? We can say here that to define the position of B relative to A, I can say that I will take the position vector RB relative to A, which is vector AB, and my purpose is to find a relation between the absolute velocities of A and B. Okay, so first what I will do, I will write the relation between RA, RB, and RB relative to A. So as we did yesterday, it's the same relation. لأنه إذا بتطلعوا بهذا triangle of vectors عنا RA plus AB يعني plus RB relative to A equals to OB, which is RB. And now we will derive this relation. Okay? So when we derive this relation with respect to time, what can we say? We will decompose it into parts. يعني إذا أنا باخد a small displacement of B. Okay? Look, هيدي الفigure. أنا كنت in this position. What happened is that I have to combine the translation of A. So first A will move a certain vector DRA. Okay? And if I want to find DRB, so what is the change in position of B? I will decompose it into DRA, which is due to translation of A, plus DRB relative to A, which is due to rotation of B relative to A. So in this way, I decomposed the motion of B into two components. One due to translation about A, and one due to rotation of B about it. Okay? Now, if I derive with respect to time, I will obtain the following. I will obtain that the absolute velocity of VB, which is equal to derivative of RB with respect to time. So when I derive the absolute position, when I talk about absolute, يعني with respect to the origin of the fixed frame. لأنه نحن أخذنا fixed origin. Okay? هيدا الفيكست origin هو الأوريجين للposition vector OB و OA. So when I derive OB and OA, I will get absolute velocities of V and A. Okay? Now, when I derive DRBA with respect to time, I will obtain the relative velocity of B with respect to A. And this relative velocity is due to what? It is due to the rotation of B around A. So as you can see here, that term DRB, okay, DRB is with respect to A, is this one, this displacement, is due to the rotation of B about A. So I can write it as, you know that in circular motion, the linear displacement is a very small displacement, can be correlated to, can be, we can consider that displacement is equal to the arc of circle here. And the arc of circle is equal to the radius times the angular displacement d theta. So I can replace DRB relative to A by RB relative to A d theta. So when I divide by dt, I get that DRB relative to A by dt is equal to RB relative to A, which is length AB, times d theta by dt. Okay? And d theta by dt represent what? This is the angular velocity omega of the rigid body. Okay? So now I can say that VB relative to A, this term, is due to the rotation of B, the velocity of rotation of B with respect to A. Okay? Which will be always, of course, perpendicular to AB, because it represents the rotation of B about A. So now, in this way, I decomposed my velocity vector of B into the absolute velocity of A plus the relative velocity of rotation of B with respect to A. Now, in general, since VB relative to A represent a velocity of rotation, and we have seen together yesterday that VB relative to A, when we have rotation, can be written in vectorial form, can be written as omega vector vectorial AB, which is R of B relative to A. So now I can say that in general plane motion, I can relate any 2 points by the following relation, okay, which is VB equal VA plus omega vectorial AB, okay? Now, if we take some examples here, for example, okay, we have, if we consider, if you want to find the relation between velocity of A and velocity of B, what we can say here first, A and B are 2 points of one rigid body. So we can correlate them. So if you have this problem here, for example, and they ask you to find what is omega of AB. This is the question, let's say. Knowing omega BC, okay? We want to know what is omega AB. How we can think? To find omega AB, we try to know information about velocity of A and velocity of B. What we are sure of is that A is moving on a straight line. So VA will be moving along this line. Okay? But we don't know its magnitude. So one of the unknown is, the first unknown is VA magnitude. The second unknown is omega AB. Now, for VB, for point B, we know what B is doing. B is rotating about C. So what we can be sure of is that the velocity of B is perpendicular to BC. So if I draw it here, it's doing an angle of 45 degrees with the vertical. Okay? Now, if they gave us omega BC in the problem, of course, they should give us omega BC if we want to calculate omega AB. So knowing omega BC, we can say that VB is equal to omega BC times BC. Okay? And now, if you apply the vectorial relation relating VA to VB, you will obtain two unknowns, two equations. Why two equations? We will do a lot of practice on this because a vectorial relation in 2D will give you two equations, one in X, one in Y. And this will allow you to solve for VA and omega AB. But why AB is doing here a general motion? Because look, A is doing translation while B is doing rotation. اوكي يعني AB مجبور تكون عم تعمل general plane motion لانه لو كانت translation AB مفروض ال A وال B يكون عندهم same velocity ولو كانت rotation about fixed axis كان مفروض يكون عندي point on the rod that is of zero velocity وكل ال points عم يبرموا حواليه يعني ساعتها any point will have rotation about it which is not the case here لانه عندنا كل point عم يعمل motion different than the other. Okay, so this is the case of general plane motion. Another example of general plane motion is a wheel rolling without slipping. For the case of a wheel rolling without slipping, at the contact point with the ground بتكون الفيلوسيتي زيرو. اوكي هيدا حنشوف انه هيدا بنسميه instantaneous center of rotation. يعني بكل لحظة all points seems to rotate about this point and this point is changing with time. This is why we have a general motion. مثلا هون point B is just doing translation, is moving along a straight line. While if you look at another points or other points you have different velocity vectors. Okay, كل point عنده different velocity vector and we don't have a fixed axis of rotation. The center of rotation is varying with time. So this is also a general plane motion. Let us do some practice to see how we apply the vectorial relation in case of general motion. The following link is guided by two blocks A and B, which move in the fixed slots. If the velocity of A is 2 meters per second downward, determine the velocity of B at the instant when theta is equal to 45 degrees. So in this problem, what do we know? If we look at our figure, we have a rod, AC, and two of its points are restricted to move in slots. A is restricted to move in a vertical slot, while B is restricted to move in a horizontal slot. So I can be sure that velocity of A will be along J and velocity of B will be along F. Okay, this is the first information I know. Concerning VA, I completely know the velocity vector. VA is equal to minus 2J, so no problem with VA. Now for VB, I know that it's moving horizontally, but I don't know what is the magnitude of its velocity. And they asked me to determine what is the velocity of it. So what I will do, I will write VB function of its magnitude. So VB vector is VB magnitude times I. And as you can see, A and B have different motion. So I say that I have a general plane motion for my rod, and I have a certain angular velocity, omega AB, that is unknown. So how many unknowns I have? I have two unknowns, VB and omega AB. So I need two equations. These two equations can be obtained by writing the vectorial relation between relating A and B. So since A and B are 2 points of one rigid body, I can write that VB is equal to VA plus the velocity of B relative to A. And now I will replace. VB is VB times I. VA is minus 2J. Now for VB relative to A, I can replace it by omega AB vector, vectorial AB. This is the formula, okay? So this term represents the relative rotation of B with respect to A, okay? Now, to be able to proceed, I should find what is omega AB vector. It's along which direction omega AB? I, J, K, along what? How will be omega?
مش K.
Very good, K. Okay? لأنه when you have a 2D motion, omega is always perpendicular to the plane of motion. بما أنه الموtion is in IJ plane, so omega AB will be along K. ونحن we did an assumption, طلعوا بالassumption اللي عملناها. We assumed omega AB counterclockwise. يعني إذا نحن أخذين I like this, I and J, then omega AB will be along positive K. هيدي assumption. كيف فينا نتأكد منها بالcalculation؟ إذا طلعنا positive result يعني our assumption is right. So I can write that omega AB vector is equal to omega ABK. Okay. And concerning vector AB is this vector here. I can decompose AB into two components, one along I, one along J. I have that AB is 0.2 and the angle with vertical is 45 degrees. So AB vector can be simply decomposed into two components, one along I, one along J. So let me clear this and write it again. فإذا حنرجع نكتب الريليشن. قلنا إنه VBI equals to minus 2J. Now we will replace omega AB, okay? Plus omega ABK vectorial AB, and I will replace AB vector by its component. I decompose AB into 0.2 cosine أو sin إذا بدكم هي ذاتها 0.2 sin 45i. This is AB has a positive component along I, negative component along J. So minus 0.2 cosine 45J. Now, all I have to do is to do the expansion. تذكركم بشغلة بالفيكتوريال برودكت، بس يكون عندكم فيكتوريال برودكت فيكم تعملوا هيدا السيركل I J K. اوكي، تاخدوا سيركل I J K، هيدي البوزيتيف direction if we rotate like this. اوكي، عندي K vectorial I، احسن ما تعملوا الرايت هاند رول each time. K vectorial I عم ببرم بالpositive direction will give me plus J. اوكي، بينما K vectorial J I'm turning بالopposite يعني it's minus I. So بيطلع لي VBI equals to minus 2J plus قلنا K vectorial I هي positive J, so plus 0.2 sine 45 times omega AB along J. And for the second term and the K vectorial J مثل ما قلنا KJ I'm turning بالنيجاتيف direction يعني بتعطيني minus I already في minus, so plus 0.2 cosine 45 times omega AB along I. Okay, now all I have to do to get my two unknowns is to compare along I and compare along J. So if I compare along I by comparison along I, what do I have? From the first side I have just VB equals to the component along I from the right side, which is 0.2 cosine 45 omega AB. So I can say that VB is equal to 0.5 cosine 45 omega AB. This is equation number 1, relating the two unknowns. The second relation is by comparing along J. By comparing along J, what do we have? First, 0 from the left side, I have 0J. So 0 equals to, from the other side, I have these two terms, minus 2 and 0.2 sine 45 omega AB. So I can put 0 equals to minus 2 plus 0.2 sine 45 omega AB. You can see that the second equation will have only one unknown, which is omega AB. So I can get omega AB from the second equation. And once I get omega AB from the second equation, I just have to replace it into the first equation to get VB. Okay, in this way, I have solved for my two unknowns, the velocity of B and the angular velocity of the rod. Any question on this? If anything is not clear, I can repeat. Please ask if you want. So let us see here the details again. So you write the vectorial relation between the 2 points, and once you have the developed relation, you compare along I and J to get your two unknowns. Another problem. The color C in the figure moves downward with velocity of 2 meters per second. Determine the angular velocities of CB and AB at this instant. So here, what do we have? First, we have two rigid bodies, BC and AB, connected to each other through B. So B here is like a pin, okay? It's a pin connecting the two rods. We know that for BC, we know that C is moving downward and the velocity of VC is known. So we know VC completely. For point B, we just know that it's rotating about A because A is a fixed point. So B is rotating around A. So because it's a pure rotation, B is rotating about a fixed axis passing by A, I am sure that VB should be perpendicular to AB. Okay, so at this position here, since AB is vertical, I can say that VB will be horizontal. So I am sure that VB vector is along R. So until now, what I know is that VC vector is equal to minus 2J. Okay. And concerning B, I know that VB can be written as VB magnitude times I. Now, since B is rotating about A, I can replace VB by the radius of rotation, which is AB, times omega AB along I. Okay? So my first unknown is omega of AB. And if I want to relate VC and VB, when I relate VC and VB, another unknown will appear, which is omega of BC. So here I have two unknowns in my problem, omega BC and omega AB. And this is the question. The question is to determine the angular velocities of CB and AB at this instant. So to be able to solve for these two unknowns, I should relate velocities of C and B. So I will write that VB, since these 2 points are on one rigid body, VB is equal to VC plus omega BC vectorial CB. And now let us replace each term, each vector, by its expression. To start with, VB is, AB is 0.2. So VB is 0.2 times omega AB along I equals to VC is along J. VC is minus 2J plus, now concerning omega BC, it's along, we assume that it is counterclockwise, so along K. So I will put plus omega BCK vectorial CB. Now CB vector, I will decompose, it's already decomposed. Look, it has 0.2, it's a positive component along I, negative component along J. So CB is 0.2I minus 0.2J. And now all I have to do is to expand my relation. I will write it here above. So I have 0.2 omega AB along I equals to minus 2J. Now K vectorial I فيكم تعملوها in your head كمان I, J, K. Ki, I turning in positive direction. I, J, K, I. This is positive. K vectorial I plus J. So it's plus 0.2 omega BC along J. Now K vectorial J كمان in my head JK هي البوزيتيف J vectorial K هي البوزيتيف يعني K vectorial J is negative وعندي minus already so plus 0.2 omega BC along I. Okay, now all I have to do is to compare. When I do comparison along I, what do I get? 0.2 omega AB equals to 0.2 omega BC. So I deduce that omega AB is equal to omega BC. And when I compare along J, I have 0 from this side equals to minus 2 plus 0.2 omega BC. So I deduce that omega BC is 2 over 0.2 is equal to 10. So I solve for my angular velocities. I can say that omega AB from comparison along I, omega AB equals to omega BC. And from comparison along J, they are equal to 2 over 0.2, which is 10. Okay? Any question on this?
دكتور
No.
هلا هي اي بي مش it is rotating
مظبوط.
عم تبرم
صح.
ايه اول شيء بتبلش اوكي رايحه with I اوكي
نعم صح.
بس تبرم بدها تطلع طلوع
أكيد منشان هيك شو قالوا لك هن at this instant على كل instant you have a new angular velocity. أوكي؟ يعني
اوكي
كل شغلنا at one position لأنه معك حق بس تبرم شوي حتصير VB مش along I فبصير بدنا نعمل calculation جديدة. على كل position we have a new values for the angular velocities. Okay?
اوكي ميرسي
Any other question? So as you can see here, this is the solution. As we did, they related the velocities of the 2 points and they compared along I and J. The comparison along I gave us that we have VB equals 0.2 omega CB. And the comparison along J gave us omega CB. هلا هن مثلا أول شيء حطوا VB as unknown يعني ونحن دغري عملنا لها replacement. هن أول شيء حطوا VB unknown رجعوا عملوا لها replacement big omega AB times AB هي ذاتها. أوكي. نحن من الأول we replaced into vectorial relation. هن عملوها as a second step يعني من بعد ما جابوا VB جابوا omega AB. It's equivalent بيطلع لنا آخر شيء إنه omega AB is 10 radian per second. Now we will introduce the concept of instantaneous center of zero velocity. We already talked together about what is the IC. The IC is whenever I have a general plane motion, I can define one point that will have a zero velocity at any instant. يعني على كل instant فيني الاقي point واحد الفيلوسيتي تبعه زيرو. وانتبهوا على شغله الانستنتينيوس سنتر مش ضروري يكون على البادي يعني في يكون بالبلين containing the body. هلا بتشوفوا كيف يعني مثلا هون اذا عندي wheel rolling without slipping هون it's fine the IC is on the wheel لانه due to non-slipping condition the velocity of A is equal to the velocity of the ground اللي هي zero. So whenever you have a wheel that is rolling without slipping, then you can say that the instantaneous center is on ground level, okay? And it is characterized by a velocity of zero. شو يعني هيدا الشيء؟ يعني if you relate the velocity of any point on the body to the IC, okay? يعني مثلا let's say B, okay? If you want to relate VB to VA, شو بتطلع الريليشن؟ بتطلع VB equals to VA هزيدها هون VA plus omega vectorial AB. بس بما انه A has a velocity of zero لانه هو الاي سي اوكي هو الانستنتينيوس سنتر velocity تبعه زيرو لانه هو على الجراوند وما عندي slipping so VA is zero. شو بيصير ساعتها؟ بتصير الاكسبريشن of velocity of any point B on the wheel restricted to omega vectorial AB. شو يعني؟ يعني B any point seems to rotate about A. بما انه any point seems to rotate about A يعني ال velocity vector تبع حيلا point على الويل هيكون perpendicular ل distance from A to the point. يعني for example, if you take a point here, point C here, V of C should be perpendicular to AC. And any point you take will have a velocity perpendicular to the line joining the point A to the point of interest. فطلعوا كيف بيكونوا ال velocities of the wheel points. في عندي البوينت يلي فوق أبعد شيء فوق بتكون ال velocity تبعه 2 omega r. Why? لأنه look, what is the distance of this point from A? It's the larger distance اللي هي 2 times r equal to the diameter of the wheel. اوكي يعني اعلى velocity بتكون at the top point اذا سميناه d vd equals to 2r omega. اذا باخد السنتر مثلا center of the circle of the wheel انتوا بتعرفوا already انه بالnon slipping condition v equal omega r. You can verify this again لانه distance from A to the center هي r. So if I multiply r by omega, I get the velocity of the center, اللي سمينا center O. So velocity of O is equal to omega times r. And this is the characteristic of non-slipping condition. When you have a wheel rolling without slipping, بتكون velocity of its center omega times r. Okay? Now, this is a particular case, بس instantaneous center فينا نستعمله ب several cases. Okay? So instantaneous center فيه ما يكون على البودي. I will give you some examples. If you take a rod, okay, and let's say عندها هيدا الpoint for example is moving like this, and this point is moving like this for example. وأنا بدي أجيب ال instantaneous center. We will see how to find the instantaneous center and how it can be on the body or outside of the body. Okay? So how to locate the instantaneous center of rotation for any rigid body? We know that the velocity of a point on the body is always perpendicular to the relative position vector extending from the IC to the point. هيدي الكاركترستيك كتير مهمة. يعني بما إنه ال IC has zero velocity يعني حيلا point velocity تبعه حتكون perpendicular to the line joining A to the IC, the point to the IC. Okay? This is why إذا أنتم بتعرفوا بكفي تعرفوا ال velocity of 2 points على البودي تتلاقوا ال IC. Why? Because let's say أنا عندي هيدا الرود وبعرف إنه هيدا ال point is moving like this and this one is moving in this direction. Okay? فيني أقول إنه to locate ال IC should be أول شيء on the line perpendicular to the velocity of the first point. يعني إذا هيدا ال point سميته A and this one is B. Okay? The IC should be at the perpendicular to the A and at the perpendicular to VB. هون مثلا بهالإكزامبل ال IC مجبور يكون at B لأنه ال intersection of the two lines is B. Okay? أعطيكم example تاني. In this body, if I know VA is like this and يمكن محطوطة بتاني slide لحية. Okay? Do you want me to zoom or you see well the figure? Do you see well this figure?
Doctor, if you can zoom in, we can see it better.
Yeah, I will zoom it in. Okay. Look, for example, if I know 2 points on the body, I know the velocity of the first, the direction of velocity of the first, and the direction of velocity of the second. From the property of IC, the IC should always be located on the line perpendicular to the velocity. So if I know the direction of VA, I can say that the IC should be on the line perpendicular to VA. And if I know the direction of VB, the IC should also be on the line perpendicular to VB. So the IC then can be determined as the intersection of these two lines. ومثل ما شايفين هون الانستنتينيوس center is outside of the body. هو بقلب البلين تبع البودي، بقلب البلane of motion of A and B، بس في يكون برا البودي. Okay? So this is a method to find the instantaneous center if I know the velocities of 2 points. هلا in case the 2 points are have parallel velocities, what will happen? So for example here طلعوا بهذا الexample عندي VA و VB that are parallel to each other. So if I draw the perpendicular to VA and I draw the perpendicular to VB, it's the same line. So here it's the IC should be on this line. But how to know what is the location of the IC in this case? I will join the extremity of VA to the extremity of VB. Why? Why I should do this? لأنه نحن بنعرف إنه for the IC is in a way that the velocity of A should be equal to omega of the rigid body times the distance from A to the IC. Okay, so times this distance. So VA is equal to omega times RA, the distance between A and the IC. And also VB should be equal to omega times the distance between B and the IC. So if you just do the ratio of VA over VB, what do you obtain? If we do the ratio VA over VB, VA over VB should be equal to the distance from A to the IC over the distance from B to the IC. هيدي الريليشن بشو بتذكركم؟ هيدي البروبورشناليتي. هاي البروبورشناليتي فينا نلاقيها بالسيميلر triangles. Okay? This is why when I join the extremity of A to the extremity of VB بيطلع لي similar triangles. طلعوا هون هيدا edge length is VB, this edge length is VA, and this length is RA, distance between A and IC, and this is the distance between B and IC. So when I join the extremities from similar triangles, or also from, if you want, you can consider also from Thales theorem, I can write that VA over VB is equal to the distance between A relative to the IC over the distance between B and IC. So to ensure this ratio, I should join the extremity of A to the extremity of B. So I can see that the IC will be the intersection between the line perpendicular to VA VB and the line joining extremities of A and B. And you can see here also this is the same case, but هون كانوا velocities of A and B opposite to each other. هون they are same sense. So in this case وقت يكونوا ال VA VB opposite بيطلع ال IC between A and B, while in case VA and VB are same sense بيطلع ال IC لميلة واحدة منهم. Okay, so here if I want to find the IC, same method. First I draw the perpendicular to VA and VB. It's one line. So to find the IC I need another line. I join the extremity of VB to the extremity of VA. The intersection point between the two lines will give me the location of the IC. Okay, now how we use the IC we will see. The IC can help us a lot in solution of problems. حدا ما فهم كيف جبنا ال IC in these cases؟
دكتور بس أنا بيديني فكرة ما فهمت.
Okay. Look, نحن الانستنتينيوس سنتر مفروض يكون على perpendicular to VA، يعني إذا بترسم perpendicular to VA والperpendicular to VB مفروض يكون الانترسكشن بيناتهم. بس لما يكونوا VA و VB parallel بتكون هيدي اللاين it's one line. يعني انت بعد بحاجه ل another line to find the IC. اوكي، كيف بدنا نلاقي تاني لاين؟ نحن فكرنا انه كيف بدنا نقدر نلاقي الاي سي، بدنا نلاقي what is the relation between these distances. يعني انا كيف بدي الاقي هاد distance، the distance from A to IC and the distance from B to IC، بدي اقدر الاقيهم to locate my IC. To do this قلنا let us assume انه هيدا ال IC position، وانا ما بعرف هيدي الديستنس قد ايه وهيدي الديستنس قد ايه. اوكي، بس جيت قلت انه انا from the property of IC I know that A is rotating about the IC و B is rotating about the IC. So I can write انه the velocity of A هي the angular velocity of the body times the distance between A and the IC. اوكي، بنفس الوقت B is rotating about the IC، يعني كمان VB لازم تكون equal to omega times the distance from B to the IC. اوكي، طب جيت قلت انا to satisfy these conditions، اوكي، اذا بعمل الريشيو of VB over VA شو لازم يطلع لي؟ اذا بعمل VB over VA لازم يطلع لي الريشيو of distances. طب هيدي الكونديشن is only satisfied in which case؟ هيدي الكونديشن ما بتزبط الا اذا عندي IC is I put it in a way to have similar triangles. اوكي، فيكون عندي similar triangles بده يكونوا هول الangles opposite and equal. So C should be obtained by joining the extremity of A to the extremity of B. In this way, by applying similar triangles بيطلع لي انه VB over VA is equal to this distance from B to the IC to the distance from A to the IC. يعني is equal to BI C over the distance from A to the IC. Okay? So تكون هيدي الcondition satisfied إجباري يكون C in a way to have similar triangles. So it should be joining the extremity of A to the extremity of B. Okay? وضحت؟
Yes, دكتور واضح. ماشي.
Okay. Any other question? Okay. Now, going back to the previous slide, okay? We have several methods قلنا to locate the IC. الميثود اللي شرحناها أول شيء هون أنا وياكم إذا بنعرف the velocity of 2 points. Another method هي if I know just the velocity of 1 point والangular velocity of the body. Because if I know these two, it is enough for me to determine the location of the IC. How? First, knowing the velocity vector of 1 point, I can be sure that the IC is on the perpendicular to VA. Okay? Then, in a second step, to locate the IC, تعرف وين على المظبوط هو on this line, I know the second property to use هي إنه velocity of A هي omega times the distance between A وال IC. بما إنه the omega is known, يعني I can say that the distance between A and the IC is equal to VA over omega. وهنا معي أنا VA ومعي omega. I know them both. Now, مين بيقول لي كيف بدي أعرف إذا هالديستنس لفوق أو لتحت؟ يعني if I should put the IC from this side or from the other side. How can I know? Knowing the VA direction and omega also. يعني مثلا بهالفيجر أنا بعرف إنه omega clockwise و VA upward. فكيف بعرف وين لازم يكون الاي سي اذا لفوق او لتحت؟ شو بعمل؟ اي رول؟ انتوا عادة بالروتيشن تتعرفوا اذا اوميجا، اذا معكم الاوميجا، اذا تتعرفوا اذا VA up or down شو بنعمل؟ بنعمل right hand rule صح؟ يعني هون you should use the right hand rule to know إذا center is to the upper part or to the lower part. And when you put your right hand, if you take your right hand, you put your 4 fingers along VA and you curl your right hand in the direction of omega. Okay? كيف حيكون ايدكم عم تبرم هيك؟ يعني the face of your hand is looking upward. نحن بنعرف انه بالرايت هاند رول الكف تبع الايد بيكون towards the center of rotation. فانا هون بما انه بعرف انه VA is up، اذا بحط my four fingers, the 4 fingers of my hand along VA I curl it clockwise، اجباري كف الايد تبعي يكون عم يطلع لفوق. So the IC will be upward. لو كانت omega in the opposite direction، لو كانت اوميجا كاونتر كلوك وايز، ساعتها صار بدي ابرم ايدي هيك، ساعتها بصير الاي سي داونورد. اوكي؟ Any question on this? So these are the different methods to locate the instantaneous center of rotation. Now how we will use the instantaneous center we will see together. The instantaneous center is very interesting. Look why? Because once you know the velocity of 2 points، يعني إذا أنا بس بعرف VA و VB، حتى بكفي أعرف just their directions وأعرف ال one velocity magnitude، بكفي وحدة. Why؟ لأنه مثلا إذا بعرف the directions of A and B velocities، ساعتها I draw the perpendicular to VA, the perpendicular to VB, their intersection will give me the instantaneous center. Once I find the location of the instantaneous center, okay, so this is the location of the instantaneous center. I calculate this distance from geometry. وإذا أنا معي VA مثل ما قلت لكم one of the velocity should be given، بكتب إنه VA هي equals to omega times the distance between A and IC. بما انه هيدي distance is calculated by geometry، هذا we will see how. و VA is given, so I can now deduce the value of omega. Omega equal to VA over the distance between A and the IC. Once I find omega, once I calculate omega، صار فيني اجيب ال velocity of any point. يعني هلا حيلا point مثلا C، if I am interested in the velocity of C، روح على الفيجر، I find the distance from the IC to C and I multiply it by omega, I get the magnitude of VC. And to draw VC vector, all I have to do is to do the perpendicular to the line joining IC and C. ومن الرايت هاند رول بعرف إذا it's downward or upward. بما إنه هون it's a counter clockwise rotation، ف VC حتكون in this way to rotate counter clockwise about the IC. Okay? Let us do some examples to see how we can work with the instantaneous center. Show how to determine the location of the instantaneous center of zero velocity for member BC shown and member CB shown in the figure. Okay, so first, let us look at the first figure A. This is the first figure. عندنا two rods AB and BC connected through point B. And our purpose is to determine the location of instantaneous center of BC. To do this, first, B is rotating about A. So, بما أنه it's rotation about a fixed axis، يعني VB should be perpendicular to VA. مظبوط? So I know already that VB, this is VB, VB is perpendicular to AB. So because it's rotating about fixed point A, so this angle is 90 degrees. And what I know about C is that C is restricted to move in a horizontal slot. So VC is horizontal. So since now I know the direction of two velocities, I can determine the location of the IC by just drawing the perpendicular to the two velocity vectors. So the IC first should be located along the perpendicular to VC. Okay, and also should be located on the perpendicular to VB اللي هي AB. So just I can say إنه ال IC here is the intersection between AB and the vertical passing by C. So this is my IC in this problem. This is my IC point. This is my instantaneous center. Okay. And now أكيد بيكون عندي from geometry يعني بيكونوا عاطيني مثلا الانجل theta. Okay, so here this angle is theta. It should be given. Knowing theta, this angle, and knowing عندي هون بده يكون عندي information مثلا بيعطوني what is the BC distance يعني بيكون معي what is BC length. Okay, plus بيكون قادر أعمل calculation also to another angle in my figure. ساعتها بيصير فيني لأنه إذا بيعطوني مثلا here, let's say I know this angle here. Okay, ساعتها كمان بيكون معي alpha. صار معي two angles ومعي BC length. تنقول this is 2 meters for example. So فيني أعمل ساعتها sine law to get the distance from B to IC or the distance from C to IC. ساعتها knowing these distances and knowing the velocity of one point, I can get omega. هنعمل numerical examples on this. Just in this problems, I want you to understand how we find the IC. Okay? Now, take a figure to get the IC, another figure. In this figure here, خليني أكبرها شوي كمان. Okay. In this figure, I want to determine the location of my IC. I have a system of rods, 3 rods, CD, CB, and AB. What I can see from the figure is that C is rotating about fixed point D, so the velocity of C should be perpendicular to CD. And B is rotating about fixed axis passing by A, so VB should be perpendicular to AB. So now, if I draw the perpendicular to VC and the perpendicular to AB, بيطلع لي 2 parallel lines. شو يعني؟ يعني because these are 2 parallel lines, they will never meet. They will meet at infinity. يعني the instantaneous center is at infinity. So I deduce إنه at this instant my rod is translating. Okay? لأنه omega of my rod at this instant, omega CB is 0. Because omega is defined as velocity over the distance from the point to the IC. Well, IC is at infinity, يعني RC IC is infinite. So the ratio V over the distance is 0. So I can conclude that at this instant, omega CB is 0. So all points of my rod will have the same velocity. Yani VC is equal to VB. And we say that it's instantaneously translating. Okay? Now, مثلا بهيدا البروبلم اذا بستعمل الاي سي كونسبت دغري بحل البروبلم. يعني اذا سالوني وات از اوميجا بي سي ات ذس انستنت، اذا بدي اعمل الفيكتوريال فورميليشن حيطلع لي اوميجا 0 بس كثير بتطول. يعني بصير بدي اكتب فيكتوريال ريليشن واعمل كومباريزن along I and J. بينما اذا بعمل الاي سي ميثود بتستغربي in less than 1 minute I say omega BC in this figure is 0. So sometimes ال IC كتير بتسهل السوليوشن. This is why we should know both methods, and depending on the problem we will select the appropriate method to use. Okay? Any question on this? Okay. So as you can see here in this figure, we did the parallel to the perpendicular to the two velocity vectors. They will never meet. So we can say that at this instant, omega is 0. Another problem, the cylinder rolls without slipping between two moving plates E and D. Determine the angular velocity of the cylinder and the velocity of its center C at the instant shown. مظبوط هون عنا rolling without slipping، بس please انتبهوا الجراوند منه fixed لأنه between two moving plates. So always pay attention. The instantaneous center بيكون على الأرض لما يكون الجراوند fixed. Here in this problem it's not the case. We have rolling without slipping but the contact is with moving plates. شو يعني؟ يعني we can say because of non-slipping condition لأنه no slipping between the cylinder and the plate على contact point بيكون عندنا same velocity. This means that at A is in contact with the plate E and plate E is moving at a velocity of 0.25 meters per second. And we can deduce that V of A is 0.25. While B is in contact with the bottom plate يعني بما أنه في non-slipping condition كمان at B, so VB will be equal to the velocity of plate D اللي هي 0.4. So what I know until now is that V of A is equal to VE equals to 0.25 meters per second, while VB is equal to VD equals to 0.4 meters per second. So in this problem, I know the velocities of 2 points. So what is the method to locate the IC? I say that first the IC should be on the perpendicular to VA and VB. هون it's one line. So مثل ما قلنا وقت يكونوا parallel velocities, I join the extremity of the first to the extremity of the second to locate the IC. The IC is somewhere here. But I should locate it. I should find its location. So this is the IC. Now to find the IC حاعتبر هيدي distance حسميها X. And I want to calculate X. Okay. This is X. بما انه the distance between A and B is equal to the diameter of my wheel اللي هو 0.125 times 2. يعني بقدر اقول انه distance from IC to B هي 2 times the radius اللي هي 0.25 minus X. So here I have one unknown اللي هي X. مظبوط؟ To get X هستعمل similar triangles rule لأنه due to the IC location I have two similar triangles here. So I can write from similar triangles or from Taylor's theorem كمان I can write that this distance X over the distance from IC to B اللي هي 0.25 minus X is equal to the ratio of velocities اللي عندها هي VA over VB يعني equals to 0.25 over 0.4. So as you can see here, the only unknown in this equation is X. I can get the value of X. Once I get X, صرت أعرف وين ال IC of my wheel, then I can find the velocity of any point on the wheel. In particular, هن طلبوا مني أول شيء قبل ما أجيب ال VC طلبوا مني ال angular velocity of the cylinder. Okay? كيف بدي أجيب ال angular velocity of the cylinder? Once I get X, فيني أجيبها in two ways. فيني أقول إنه omega هي equal ل VA over the distance between IC and A اللي هي X. So I can write omega as VA over X أو كمان I can get it from B لأنه كمان معي VB. So it's equal to VB over 0.25 minus X. Both will give me the same result. Now once I have omega, once omega is calculated, I can calculate the velocity at any point on my wheel. How? Just I need to determine the distance between the point and the IC. يعني for example, طلبوا مني the velocity now at the center. Okay? طلعوا هون الcenter will move to the left. كيف عرفت انه it will move to the left؟ لأنه طلعوا بالفيجر. هون ال C is below ال IC. Okay? C ثاقب تحت ال IC. وعندي ال omega of rotation is like this, is clockwise. So C حيكون عم يرجع لورا backward. And to get the velocity of C, all I have to do is to get what is the distance between the IC and C. This distance from the figure is the radius minus X. يعني the distance from the IC to the center. خليني محي شوي ترجعوا تقشعوها. قلنا ال IC تقريبا هون. مظبوط. This is the IC. وهيدي الديستنس سميناها X. Okay? So the distance from C to the IC, this one, is 0.125 minus X. So now I can say that the velocity of the center C is equal to omega, اللي عملنا لها calculation, times 0.125 minus X. Okay? And how to know direction? من ال right hand rule. Okay, نحن لقينا انه omega is rotating, the wheel is rotating clockwise, وال IC is above C, ف VC مفروض تكون to the left تيقدر C يبرم counterclockwise about IC. Okay? Any question on this? So let us see together here the details of the solution. So as we said, as a first step, بدنا نجيب the location لل IC. Okay? So by using the ratio, we get the value of X, as you can see here. And once we get X, we can calculate the corresponding value of omega. And once we know omega, to get the velocity at C, all we have to do is to do omega times the distance. Okay? مثل ما نحن هلا نحن هون هنا عملوها بغير ميثود، هي ذاتها بالتو كيسز. يعني هن جابوا هن الاكس تبعهم هي الكبيره مش مثلنا، يعني جاست هن سموا هاد ديستنس اكس بس نفس الكونسبت. يعني نحن اخذنا الديستنس صغيره اكس، هن اخذوا الكبيره هي اكس، ساعتها بتكون هيدي 0.25 minus x هي ذاتها. اوكي؟ سو هن اخذوا هيدي اكس الديستنس جابوها، فساعتها الديستنس to the IC from the center هي x minus 0.125 وبيرجع بيطلع لي اكيد same result. اوكي؟ Any question before we close the session?
Yes, Dr.
Yes.
هو الاي سي بس بال 2 دي مشان
في ب 3 دي كمان اي سي. اوكي بس نحن هلا بهيد شابتر بس حناخذ 2 دي بروبلمز.
اوكي بس سؤال صغير عنه هيدا، يعني ما فيناش مثلا نجيب الاي سي بال 3 دي من ورا البربنديكولر على الفيلوسيتي مشان؟
بلا فينا بس اذا بدك يعني بالنهايه لو انت عندك 3 دي موشن اوكي الاي سي بالاخر حيكون على طول بيربنديكولر لحيلا فيلوسيتي. يعني فيك تستعمل هالتكنيك بال 3 دي كمان
بس مش بيكون في بلين يعني بيربنديكولر، مش انه مثل لاين معينه.
لا ما انت ساعتها بيصير عندك مزبوط، بيصير عندك مش بوينت واحد، بيصير عندك instantaneous axis of rotation. عرفت كيف؟ يعني بدل ما تحكي ب 1 point بتحكي ب axis of rotation، instantaneous axis of rotation. هلا هون بالنهايه حتى هون في instantaneous axis of rotation، بس نحن بس بنجيب الاي سي لانه الاكسس perpendicular to the plane. اتفقنا؟ وقت تحكي انت بعدين بال 3 دي بصير عندك instantaneous axis of rotation، بصير بدك تلاقي several points تقدر تجيب الاكسس، يعني ما بكفي تلاقي point واحد على الاكسس، بصير بدك تجيب 1 or 2 points تقدر تلاقي الاكسس of rotation at the instant.
Okay, fine.
Okay. Any other question on this? Okay. Yellow. We continue next time. Bye.
Thank you دكتور، يعطيك العافية.